Alright, we have more factoring for today. We are going to start by reviewing our new formulas we learned. Our first one, we've got x cubed minus 216. This is the difference of two cubes. So what number cubed are we taking for our a term? Well, that is x cubed minus what number cubed gives us 216? We sit there and we think, or we plug in our calculator, 2 cubed, 3 cubed, 4 cubed, 5 cubed. Oh, magically you get to 6 cubed. So we got 6 cubed is going to give us 216. So we've got to plug it into our formula. And just remember your signs. Since we're subtracting, it's going to be minus, plus, plus. So that's a minus b times a squared plus ab plus b squared. And when you do the difference of two cubes, that trinomial is not going to be able to be factored as any further. X minus 6 can't be factored. There's no two numbers that multiply to 36 and add to 6. We go to our next one. We've got two pieces. We've got addition. So I'm guessing this is going to be the sum of two cubes. So what number cubed gives us 125x cubed? Oh, that is 5x. So 5x cubed gives us the 125x cubed. Plus what number cubed gives us 8? We should know that one by now. 2 cubed gives us 8. So we've got the sum of cubes, which is plus, minus, plus. So we have a plus b times a squared. Now remember, our a term has the 5 and the x, so that becomes 25x squared minus a times b, which is 10x, plus b squared. So that gives us 5x plus 2, can't factor any further. 25x squared minus 10x plus 4 cannot be factored any further, so that will be our answer. And our last review question, our problem, we have the four pieces. So we're going to group the first two, we group our second two. What do they share? They share a factor of x squared. I'm left with x plus 2. They share a factor of a negative 16. Remember, we want our x to be positive. So I'm left with x plus 2. We put our GCFs together, the x squared minus 16 for the first factor, x plus 2 together for the second factor. If you left that as your answer, you would be marked wrong. Remember, double check all of your pieces. This is the difference of two squares. That becomes x plus 4, x minus 4, and then we've got x plus 2. Remember, for the difference of two squares, you need two squares and you need subtraction. If this was x squared plus 16, we would not have been able to factor it any further. Alright, so that was easy review from our last video. We're going to get a little bit harder. And sometimes it gets a little bit harder because it looks like it's a sum of two cubes. But 2 is not a cubed. So we think, okay, well, this is nothing. Don't forget about the first step of factoring. The first step is always to check for that GCF. And in this case, 2 and 54, our GCF is 2. So then we're left with x cubed plus 27. Now we think to ourselves, well, this would be x being cubed, so x is our a value. What number cubed gives us 27? Well, 3 cubed is 27. So we've got our sum of cubes pattern, which is your plus, minus, plus. Don't lose that GCF of a 2 out front. A plus b, which is x plus 3. Your a squared minus ab plus b squared. We double check, none of our pieces can be factored any further. Why don't you go ahead and press pause and try the second one all on your own. Alright, let's see how you did. You pulled out a GCF of 2x squared, or at least you should have pulled out a GCF of a 2x squared. We are left with 8x cubed minus 125 on the inside. That is the difference of two cubes. Your a term is the 2x. Your b term is the 5. So you plug that into your difference of cubes formula. Don't forget the GCF out front, and don't forget the pattern is minus plus plus for the difference of cubes. So make sure that your answer matches exactly to mine. Alright, so we talked about factoring yesterday. We just did a short little review on factoring. Now we're going to take it one step further and we are going to solve. So first think about how many solutions you should expect to find. And hopefully you remember from previous lesson that you look at the degree. The degree will tell you how many solutions you should find in your answer. So we start with our first one. We've got x to the fourth minus 2x squared minus 8 equals 0. Our degree is 4, so we should expect to find 4 solutions here. We've got 3 pieces. Since I have 3 pieces, it's not the difference of squares, it's not the difference of cubes, it's not the sum of cubes, because all of those require 2 pieces. The only one that requires 3 pieces, a trinomial, would be quadratic form. So we're looking for 2 numbers that are going to multiply to the outside and add to the middle. So we break that down into our 2 pieces. Don't forget the equal 0. And those numbers would be a negative 4 and a positive 2. The only difference is, remember, instead of x minus 4 and x plus 2, it's x squared minus 4 and x squared plus 2. Now we got to make sure that we factor as far as possible. So x squared minus 4, that's a difference of 2 squares. So that factors to be x plus 2, x minus 2, and then we've got x squared plus 2 equals 0. X squared plus 2 can't factor any further. 1, it's a plus sign, and neither one of them are, or 2 is not a perfect square. So now we've got to use our ZPP. X plus 2 equals 0, x minus 2 equals 0, and x squared plus 2 equals 0. So we've got a solution at negative 2, a solution at a positive 2. We move the 2 over, x squared is equal to a negative 2. We square root each side. Do not forget your plus or minus. Since we have a negative on the inside, we've got an we've got an imaginary solution. So in this case, we have 2 real solutions, and we've got 2 imaginary solutions, which is where our 4 solutions come from. Remember, the negative inside is going to make that imaginary. 1 solution at a positive I root 2 and 1 at a negative I root 2. We move on to our next one. We've got 16x to the fourth minus 81. Again, our degree is 4, so we should expect to find 4 solutions here. We've only got 2 pieces, so it's either difference of squares, sum of cubes, or difference of cubes. And I look and I've got x to the fourth, so I know it's not cubes, which means if I could factor this, the only possibility is difference of 2 squares. So 16x to the fourth, that's a perfect square. 81, that's a perfect square. So we go ahead and we've got the difference of 2 squares. We know that 16x to the fourth, the square root of that is 4x squared. 1's a plus, 1's a minus, the square root of 81 is 9. We look at 4x squared plus 9, that can't factor any further. 4x squared minus 9, that can. The difference between these two is the subtraction sign. The subtraction says we have difference of 2 squares again. 4x squared, the square root of that is 2x. Square root of 9 is 3. 1's a plus, 1's a minus. And we don't forget that 4x squared plus 9 out front. Now we're using our ZPP step. 4x squared plus 9 equals 0. 2x plus 3 equals 0, and 2x minus 3 equals 0. We move our 9 over, where it becomes a negative 9. We divide by 4, so x squared is equal to a negative 9 over 4 square root. And we've got x is equal to plus or minus. We've got a negative on the inside, so that becomes an I on the outside. But 9 is a perfect square and 4 is a perfect square. So the square root of 9 is 3, the square root of 4 is 2. So we've got plus or minus 3 halves I. And then the next one's easy. We move our 3 over, we divide by 2, and x is equal to 3 halves. Move the 3 over where it becomes positive, divide by 2, and x is equal to, oops, I lost my negative on the last one, is equal to a positive 3 halves. So we've got 4 solutions, 2 imaginary again, and 2 real. Alright, we are done with the front page. Let's go to back page. We've got 2 problems left. And remember, the longer we do factoring, the harder it's going to get. The more complicated it's going to get each step of the way. So I want you to stop on these last 2 and try them on your own. And just remember, think about, start with GCF. Once you're done with GCF, look to see how many pieces you have left. If you have 2 pieces, you've got certain options. If you've got 3 pieces, you have certain options. If you have 4 pieces, you have certain options. So you've kind of got to problem solve each way through to see which method you should use. Alright, go ahead and press pause and try these 2. Alright, let's go ahead and check these. First step is the GCF of the first one. We pull out that 2x. When we pull out the 2x, we've got x cubed plus 5x squared minus 9x minus 45. When you have 4 terms, the only option we have is to factor by grouping. So we group the first 2, we group the second 2. We pull the GCFs out, and we are lucky enough to have x plus 5 as the same piece inside. Again, if those aren't the same, then you can't factor by grouping, and that would have been factored as far as it could have been. So we don't drop that GCF 2x on the outside. We put the x squared minus 9 together as our second factor, and x plus 5 is our third factor. We're not done yet, though. You should have recognized that x squared minus 9 is the difference of 2 squares, so that breaks down to be x plus 3 and x minus 3. So this would be our step that is completely factored, and you want to make sure that you are completely factored each time. So we've got 2x times x plus 3 times x minus 3 times x plus 5. We go ahead and because it's set equal to 0, we use ZPP, and we set each of our pieces equal to 0, and we solve to find our 4 solutions, which matches our 4th degree polynomial. We go on to our second one, and this one we also started with pulling out a GCF of a 2x. When we were left with x cubed plus 343, we've got the sum of cubes. We are cubing x, and we are cubing 7. So just don't forget that your pattern here, since it's the sum, is plus minus plus. We don't drop that GCF on the outside, the 2x. A plus b, a squared minus ab plus b squared. We double check to see if we can factor any further. 2x is our GCF, that can't go any further, x plus 7, and that trinomial is not factorable. So this step right here is completely factored. We set each of our 3 pieces equal to 0. We've got x equals 0 and x is equal to a negative 7, giving us 2 real solutions here. We know how to solve a quadratic. We know we can solve a quadratic using completing the square. We can solve it using the quadratic formula. I used the quadratic formula, and I found that I had a negative in the inside, giving us an imaginary solution. Make sure that you break down your radical as far as you can go to get a simplified radical expression for your answer, giving us 2 imaginary solutions, which makes sense because we expected to find 4 total. So we had 2 real and 2 imaginary. Alright, our last thing at the bottom is a reminder. Always check for GCF first. That is step 1 of factoring, regardless of how many pieces, whether it's simple factoring or very complicated factoring. And then remember, if there is an equals 0, you factor and then solve. If there's not, you only factor. On a quiz or test, if it's just supposed to be factoring and you solve, you're going to get it wrong. Or if you have to solve and you only factored, you're going to get it wrong. So make sure that you know the difference between factoring and solving. Okay, and that is all for today.